Micro HDMI and USB, it has all the things you want in a PC. It's really light, it's about 1 kilo, but what's really cool is what's missing. This is an Intel Oak Trail based PC, it has no fan. It's light, it's passively cooled, and you can immediately switch back and forth between those two form factors. Woo! This new tablet, you like that one too? I think it's pretty cool. This one I'm going to take a moment to really explain. This is the new tablet PC from ASUS, and this is a full power Windows PC. So this PC has a Core i5 processor in it. It ships with this wireless keyboard. It makes a great productivity workstation for maybe a small area like on an airplane or a student's desk. And what you can see is that it responds well to Windows Touch because it has a capacitive touch screen. But because it's a tablet PC, I can also take out the pen and use ink. And what ink lets me do is stuff like, I'm highlighting here in Excel, I can take a pen and say this is great. I can take an eraser, I can erase. And one of the cool things about ink and tablet PC is a tablet PC has handwriting recognition in 26 languages. And you can see this, when I have the pen down on the screen, can you see how my hand is not moving the spreadsheet around? This is one of the reasons that it's hard to do ink on touch-only devices and why tablet PCs are so good for ink is because it's implementing palm rejection here. It actually knows what my hand is and knows what the pen is and doesn't get the two confused. Here's a touch-only game that I can launch, and you can see the characters following me around the screen. But what I want to show you here is the screen itself. This screen is really bright. And what we did with ASUS was we worked really hard with them to make sure that this screen would have off-axis viewing of almost a full 180 degrees. So as I move it around here on the camera, you can see that from almost any angle, the screen is really, really bright and the colors don't shift. And we did that by working together on a process to optically bond all the components of the screen. So the Gorilla Glass on the surface, the underlying LCD, the touch sensor, even the electromagnetic digitizer for the ink are all bonded together as a single unit. And that process eliminates the air gap that's usually underneath the screen. So the screen is not only brighter, it uses 20% less power to actually get that same level of brightness. You can order these PCs starting right now. The page just went live on Amazon.com and the Microsoft Store, and I think they're going to be pretty popular. But if you want to see an example of really extreme integration on Windows 7, you have to look no further than the brand new version of Microsoft Surface. Microsoft Surface is announced today. This is a brand new version, and if you remember from the first version, you notice there's some pretty stark differences from version 1 of Surface PC. We worked hand-to-hand with Samsung on the entire end-to-end experience I'm about to show you. The first thing to notice is that the PC is thin. No longer is it a big box with cameras inside. This is only 4 inches thin. Inside here, there's a full power Windows 7 PC. It's got a dual core CPU and a GPU from AMD. Up top, this is the biggest piece of Gorilla Glass that has ever been bonded to an LCD ever. But what's really amazing about this technology, what really makes it magical, is the sensor itself. So those first generation Surface PCs needed cameras underneath that would look up to try to see what was going on. But what we have here is called Pixel Sense. Pixel Sense is new technology we've invented where there's infrared sensors all across the screen. Every single pixel is actually acting as a camera. The PC, the Surface here, can actually see. So I'm holding up a piece of paper that says I can see, and when I set it down, what you see on this debug monitor and what you can see in the split screen above is that the PC can actually see that paper. So this is even beyond touch. And Pixel Sense is more than just vision. It's actually the processing inside that takes that data and makes it available for developers to write cool applications on it. One of the really cool things about this new thinner form factor is that it no longer has to just be a table. You can also use Surface as a kiosk. And I want to talk a little bit about the Royal Bank of Canada. This is one of our with the slots and everything. The PC doesn't need to be any bigger than this, plus a battery and a screen, and can be of any size. And what we're working on here is an example of what it looks like when we're doing development. Now this is a future version of Windows. We're running on the low power Atom SoC architecture from Intel, and what's so cool about this...
Future version of Windows,
future version of Windows.
Current user interface.
Current user interface. This is all about supporting the basic chip level, kind of at the kernel level, if you will. The thing that makes the Intel platform really interesting is the compatibility with all of the existing software and hardware applications that run on Windows today. So what I'm showing you here is a version of Quicken that I just got. systems, and I'm going to show you Windows, real Windows client running on ARM. So this is Qualcomm's ARM system called Snapdragon, and this is the Windows client running on ARM. I can pull up the command prompt and show you the version string for the kind of people that track that sort of thing, just to show that it's real. I've got desktop pinning, I've got accessories launching. You can see I can open my photo library, I've got customization, I can change my desktop background. What I'm showing you here is the Windows desktop up and running live on an ARM system. And that's really the first time. This isn't virtualization, this is Windows running natively on ARM. We're also working with Texas Instruments. This is their ARM platform called OMAP. And what I'm going to show here is an example of how hardware and software applications can work. So I'm going to launch Word and paste in some text and hit print. And what I did there is actually launched Word. That's Word running on ARM. So this is a build of Word that we've recompiled to be a native ARM application, and you saw it launch, you saw that I pasted in some text, and what I have down below me is an off-the-shelf printer from Epson. It's a USB printer, and what we did with them is we recompiled the ARM driver, we recompiled the print driver to run natively on ARM, and in just a moment you can see that it prints. So that's real. Thank you. That's real Office working, that's real print driver working, and the print driver is just one of the subsystems that we have up and running. We can connect to cameras and storage devices and other cool things like that. Now this third ARM system I want to show you is from NVIDIA, and NVIDIA is known for really high performance graphics, and the same is true on their ARM system as well. This is their Tegra platform, so you can see how smooth and responsive spinning these pictures around is, and you can see how quickly it responds to the mouse. This is all because the graphics is being processed on the GPU on the ARM chip itself. And performance is really important, especially for things like video. So I'm going to launch the Iron Man trailer, and I'm launching this in HD. This is full HD output, and what you're going to see is smooth, fast-playing video. It doesn't drop frames, it doesn't stutter, it's really high performance. This unit actually even has HDMI out, it's not connected on this demo. I can jump around to a different frame in the movie and see how quickly it can catch up instantly. And it's playing fast and it's playing smooth. So what you've seen here today is Windows, real Windows, running Office, devices, high performance browsing, high performance video, all running on next generation of SoCs.
Super, super.
Thank you very much.
Thanks for all the help today, Mike, and thanks to all of our partners for the fantastic work that they're doing.
Thank you.
Pleasure. Great.